This conference will now be recorded.
Okay, so let's very quickly, kind of try to recap whatever we had done, and from there we'll just pick it up, right? So, so we started off our discussions talking about the basic, the key important final accounts which the bank publishes, like the income expenditure statement, the P&L statement. So the P&L statement which comes by listing the income and expenditure. We talk about the asset liabilities, which is there in the balance sheet. So P&L statement, balance sheet are the two most important financial statements which are published by the bank, right? Uh, and the basic idea over here is that each of these two statements have, or each of these two statements capture the two types of losses, right? So one set of losses over here is the expected losses. The other set of losses over here are the unexpected losses. So the provisions are used to capture the expected losses of the expected losses earned by the bank, and the unexpected losses are captured by the capital, right? So now over here, what we are trying to do is we are trying to develop this particular framework, right? So over here, uh, what we tried talking about was we tried talking about the different regulatory frameworks which are there to assess the capital adequacy of the bank, like CCAR, DFAST, etc., Basel, CCAR, DFAST, etc. And on the other hand, we talked about the regulations around the provisioning side, which was the IFRS 9, right? And this was totally based on the cash flow characteristics of the assets. So assets which satisfies the SPPI criteria, or the sole payment of principal and interest, qualify for impairment calculation under IFRS 9. And when we talk about IFRS 9 impairment calculations, so IFRS 9 impairment essentially talks about, so impairment as defined in IFRS 9 is it's the, so basically when an account goes bad and is unable to pay back, right? So then that account is considered to be impaired. So any account which has hit the bad definition and with the proper backstop is what we call impairment under IFRS 9. However, IFRS 9, because it is applicable to a whole lot of different businesses, right? It is not as stringent as in terms of its definitions of in terms of the bad definitions as the Basel requirements are, the Basel Accords are, right? So IFRS 9 says that okay, 90 days or more, borrower doesn't pay, flag him as impaired, right? But again, it also keeps the non-rebuttal assumption where it says that the business can rebut it, saying that no, the business the appropriate bad definition for this business should not be 90 days, but more than that, right? But for retail portfolios, mostly it is seen that it is taken to be 90 days, right? And finally, what we tried to do was, so we tried looking into the different kind of assets. So we initially started talking about one of the retail assets, that's personal loans, and from there we tried understanding the different kinds of the different stages that IFRS 9 would encompass. So basically talking about personal loan and its impairments, we talked about the bad definition, we talked about the staging and how is it that we identify whether how staging should ideally be done, right? So what are the criteria for meeting, or what are the criteria which trigger the significant increase in credit risks and so on. So these are some of the important factors which we generally have looked into, right? Now also there is so basically we saw that when we are staging the accounts, right? So when you're staging the accounts, your stage one accounts are your non-delinquent active accounts, right? So you compute the next 12 months loss for them. The stage two you compute for stage two and stage three accounts, you report the lifetime expected credit losses of the lifetime PD for them, right? So when does an account migrate from stage one to stage two? So the staging criteria, the new staging criteria is something that you need to work on, right? So that is where we assess the origination risk and we assess the behavior risk associated with the borrowers. Now, having said that, the next part of the story over here is So over here, so then what we started looking into was that when if we are computing the next 12 months expected credit loss, or we are computing the next 12 months or the lifetime expected credit losses, so what are the components involved into it? So we know that the expected credit losses are a function of the PD, LGD, and the EAD, right? And when we talk about the PD, right, the PD has certain characteristics. So we generally compute two types of PD measures over here. One is the next 12 months PD, and the second is the lifetime PD. And when we are computing this, this PD has a specific definition. So what is that definition? The definition is that the PD has to be a point in time in nature, and it must be forward looking. So the PD is point in time and is made forward looking by adjusting for macroeconomic variables, right? So, so over here, so this is what we have. This is what we are looking into it, right? So this is the way we are actually looking into the thing. Now the next part that we have over here is the next part that we have over here is IFRS 9. So basically we need to understand the characteristics of IFRS 9 PD. And we saw that it's an unbiased estimator for the actual bad rates. It is forward looking. It reflects the time value of money, and it's the weighted average of multiple scenarios. So over here, so over here, uh, so then what we started talking about was we started talking about the fact that the IFRS 9 PD comprises two types of PD variables together. So one set of PD variables are the behavioral PD variables, and the second set of variables that we talk about over here are the macroeconomic factors. And over the last couple of classes, we have been trying to talk about, we were trying to discuss the different kinds of factors that are there, and how is it that a change in one of the factors would impact the default rate. So what would be the impact of a factor on the default rate? And what we did over there was, till the last classes, we looked into a few important variables. We looked into the GDP, we looked into the CPI, we looked into the so we looked into the interest rates and so on. And using them, we tried understanding that how is it that movement in one of the variables would have a a kind of a impact on the default rates. And we saw that an increase in the rate of interest, right, would cause the output of the economy to go down. And if an economy maintains a high rate of interest for a substantial period of time, the output in the economy would keep on going down, and a downturn would initiate, which would in turn impact the default rates in the economy, right? So this is where this particular framework actually comes into place, right? So we tried examining the impacts of each of these variables on the default rates, right? And we saw that rate of interest is something, it's one of the key instruments. It's one of the key instruments in maintaining the macroeconomic stability, right? And in this situation, what we need to perform over here is we need to understand how is it that these rates of interest can be taken. So whenever a business, whenever a policymaker has to choose an interest rate, he has to keep several matrices in mind, because a high rate of interest for a substantial period of or continued period of time can create excess productive capacity in the economy and a low aggregate demand, which can bring in a downturn leading to unemployment. And with unemployment, you would expect that the default rates in the economy to increase, right? So this was one of the theoretical frameworks that we had studied till the last class, right? Now from here, now uh, you know, right? So any questions up to this point, right? So anything that you may want me to explain once again.
Yeah, Tanmay, so it's not about something which I need to know from the past classes, but this is something related to the macroeconomic variables, like where could we get
Uh-huh.
those economic variables to be included in our model,
Uh-huh.
or is it something that is provided by the regulator, or like is it the bank who decides the which economic variables to be so selection is
No,
a
no.
second part,
So
but
basically,
where yeah.
mhm. Yeah, so the sources of macroeconomic variables would come from, you can get them from the IMF sources. So some of the values, some macroeconomic variable values are also published by the Federal Reserve. But the most reliable sources of the macroeconomic variables are mostly the international organizations. The data published by World Bank, the data published by IMF, and so on. So you can get these data sets. These macroeconomic variable figures from those sources. Those macroeconomic variables as of now, GDP, CPI, interest rate, and what we have seen is that there is an interrelation between them, right? Now there are multiple macroeconomic variables, so that impacts the between the macroeconomic variables and so on. They are all kind of created the kind of sources like IMF data sources, World Bank data sources, and so on. And so
Yeah, okay, all right.
So these data sources in World Bank and IMF are obtainable by countries, regions, so whatever form you may want to them, right? Also, if it's a country-specific factor, country-specific macroeconomic variables you want, you can get it from the respective central bank data sources as well, right? Okay, so now we talked about one of the macroeconomic variables over here, the interrelation between them. How does change in one macroeconomic variable impact the other macroeconomic variables, and how is it that these curves they move, right? And how is the impact recorded? Now the question that comes out over here is that this is a very theoretical framework that I had talked about, but there is something, you know, which is there are some characteristics which are really very important, distinctly observed in these macroeconomic variables. So they are number one, that these macroeconomic variables are correlated with each other, right? So change in one impacts a change in the other, the second impacts a change in the other, and so on. What we need to understand is that how is it that we would deal with them from the modeling perspective, right? So let's try to think about that. I'm trying to develop a model for personal loans. I have a behavior scorecard for personal loan, which is giving me the behavior PD. Now I want to incorporate the macroeconomic variables into the probability of default figures. How do I go about doing that? So that is what we need to understand, right? Because if you think about the variables, the behavior scorecard, they are either segment level or they're basically account level variables, right? Variables which change from an account to an account, right? And within a given range for a given segment. So basically, those variables are account level variables, and now to those I want to incorporate the macroeconomic variables. So what are the questions that I need to put in? So the first and the most important question that comes out to me is that that when I am incorporating macroeconomic variables into a PD model, what should be that optimal lag of the variable that I should be incorporating? right? So what is that optimal lag? That optimal lag of a variable that I should be incorporating over here. So this optimal lag analysis is something which needs to be taken care of. That's the first question. Because let's say if the GDP, if an economy goes up today, right, the default rates in the economy will, or the bad rates will not go down tomorrow itself. So there would be a time lag between the increase in the economic activity and the bad rates going down, right? Because that impact or that increase in the output will do two things. It will increase the employment opportunities, and then the income will go up, and then the bad rates will start going down. So how would you actually identify this, or how would you identify that optimal lag which impacts the bad rate? So basically, if your probability of if your probability of default, right, is something, right, so now you have a bad rate coming in, right? So how do you identify that bad rate? So this is something that we want to understand over here. So assessment of optimal lags. Now obviously there are econometric methods of identifying the optimal lags, right? But what we generally do is multiple lags, and we try to find out the correlation between the multiple lags and the actual bad rate or the probability of default. So what I'm trying to say is that, let's say I'm standing today, right, and I want to know what is the probability of default of this borrower in the next 12 months. So the question that comes out over here is that how do I do this? So basically, from my PD model, right, from the PD model that I had developed the PD estimates. And from there, I have I have an idea about how that model is predicting the actual bad rates. Now, what I want to know is that if my macroeconomic variables were to predict my default rate or my actual bad rate, how would that be done, right? So how would that be done? So this is something that we need to explore. So let's try to think about it. So what we do is, so we have the actual bad rates in the diagram. So we know that, okay, this is how our actual bad rates have been behaving. So let me just plot the actual bad rate series. Time, and over here you have your default rates. All right, let's say this is how your bad rates operate. Right, so this is something like the bad rate which is there. So this is your default rate series or your actual default rate series, right? Now the next thing that comes out is you take up GDP. Let's say I say the actual rate today and I take the GDP at that same time, right? And what I do is I plot that GDP series with you. So this is the GDP at zero lag. So that means the default rates, whatever the point the default rates have been looked into. So what I have done is I have looked into the default rates, right? So if you have a look into this, you will see that whenever the GDP has gone up, the default rates have gone down, right? So over here, when the GDP has gone down, the default rates have gone up, and so on. So what you can see is that there is a high correlation, but it is unlikely to have this correlation with GDP at time zero or at lag zero, because if the GDP increases today, it will take some time to for this to get reflected at the default overall default rate levels, the overall DR levels, right? So over here, when we look into this graph, right? When we look into this graph, right? So what you see is that so what we see is that there is a co-movement between default rates and the GDP. So basically, what we do is we generally try out multiple multiple lags, right? We generally try out multiple lags at which, you know, your correlation with the default rates are captured. So so basically what you can expect to see is the following. Let's say I tried out with GDP 0, right? I tried out with GDP 1 lag. I tried out with GDP 2 lags, right? So I may look into it quarterly levels, or I may look it into annual levels. So I may say that GDP minus 1 or 1 lag means the default rate this year is a function of the default rate last year. I mean, the function of the GDP rate the last year, right? So add one gap. So if the GDP of the economy increases today, right, then the default rate would go down in the next year. So there would be a time that would be taken for the impact to fall, right? So what happens is a kind of correlation matrix is created with default rate on one side and the different lags of the macroeconomic variable at the other end. It is GDP 0 1, GDP 0, GDP 1, GDP 2, like this GDP index, right? So over here, what we have is we have the GDP 0, GDP 1, GDP n करके I have in lags, and for each lags with the default rates, what I do is I compute the correlation coefficient. The variable which gives me the highest correlation, I mean the lag which gives me the highest correlation coefficient with default rates is the one that I would choose for model development. So that's the one that I would choose as a macro, so as a variant of that macroeconomic variable, as an optimal lag of that macroeconomic variable, right? So you may look into it, that you may look into a perfect correlation. So whenever it is, so GDP actually goes down, goes up, then it goes up, goes down, goes up, right? So this may be your GDP1. So you need to find out that which is the particular lag which is giving you the highest correlation coefficient, and choose that particular lag for that variable as an optimal lag. So optimal lag is the lag with the highest correlation with default rates. So lag with the highest correlation with the highest correlation. Highest correlation with default rates. Right? So lag with the highest correlation with the default rates. Right? So is this idea clear? That how is it that you would actually try to identify that optimal lag of a variable? Now before that, a basic question that comes out is that how do I identify that variable which should enter into the model? Right? So obviously the macroeconomic variables, as we have seen, are correlated with each other, right? Right. So all the macroeconomic variables are correlated with each other. So if you want to select a macroeconomic variable, there are two questions that you need to ask. First is, does does the two macroeconomic variables does the two macro variables, right? So does the two macro variables correlate with each other? With each other. Right? So that's the first question. And the second is that which is the one causing the other. So if they have a correlation between each of them, so if they are associated with each other, then what we need to know is that which of them is correlated or which of them is associated with the other. Which of them is the causal variable? Is the causal variable. Right. So which of them is the causal variable? So these are the two questions that we need to understand. So now when I say that other two macro variables correlated with each other, now when you are talking about time series variables, their correlation or their association between the two macroeconomic variables would not be, or cannot be identified in terms of VIL like we do for other variables, right? Because when you are doing it in a logistic regression model or in a linear regression model, the variables are static variables and they belong to a cross-section data, right? So now, if you are trying to understand time series behavior or time series association between the two variables, then what you need to do is you need to understand how is this happen. So basically, how is it that the long-term association between the two is judged, right? So the long-term association between the two macroeconomic variables can be judged in terms of co-integration, in terms of understanding how is it that they are related to each other. So do they have a long-term causal relationship? So that is where. So when you have a set of macroeconomic variables, then you need to decide that which two of them need to come in. And you need to have an understanding of the concept of co-integration, right? So one of the very important concepts that we need to talk about in determining time series or in determining these models are in determining the macroeconomic models or macro variables, the two types of regressions. One is the time series model, right? So we need to understand time series over here. That's one part. And we also need to understand the linear regression model. So now one possibility is that if you can adjust the time series data, for autocorrelation, then you can actually deploy a linear regression to get that solution, right? So this is time series regression. So one is time series and the other is the linear regression. And within time series, one of the very most important concepts that we need to talk about over here is the concept of co-integration. That is the long-term association between two macroeconomic variables. So if two macroeconomic variable, two time series are co-integrated, it means they have a long-term association between each other. Co-integration. Co-integration. So that's the first one. The second one that we have over here is the second thing that we need to know is that which of them causes the other. Let's say I am using both growth GDP and uh, CPI together in the model, right? Then we need to understand that which does GDP, an increase in GDP cause an increase in CPI, or is it that an increase in CPI causes an increase in GDP? So how is it that we would actually work that out? So over here, what we do is we create these two macro variables. So basically, which of them are, you know, so basically we need to understand the causality between each of the variables. And that is where the second concept of time series model would come out to us, which is the Angel-Granger causality. So we need to understand how is it that causality between macroeconomic time series variables are identified. So what we have is the Angel-Granger causality. Granger causality. Right, so we have the Angel-Granger causality. So these are two important concepts which needs to come into us. So if you want to develop a time series model, if you want to develop next 12 months PD model, you want to develop a lifetime PD model, and so on. You want to develop that, right? So what we need to do is we need to understand that these three measures or these three types of modeling approaches. One is your time series models, one is a linear regression model, and the other obviously is your logistic regression model. So these are the three core modeling frameworks that we need to understand. And we will be discussing each of these models, modeling methods over here, right? And along with that, we would also be talking about uh, the so we'll be talking more about the macroeconomic variables. Also, we'll be talking about the survival analysis, survival approach. We'll talk about attrition models. We'll talk about acquisition models to some extent, because application scorecard and acquisition models are something which we are already doing in details in predictive risk modeling. So that's a part that I'll not be bringing in too much here. But yes, of course, I'll be talking about these three methods first, and then we will start talking about the other side of the story, right? So so something that you can see over here is, so basically these are the three broad modeling methods we need to explore, and I'll show you how these are implemented in SAS, what are the variations of these in SAS, because when I talk about linear regression models, so when we start talking about linear regression models, we'll talk about linear regression models, simple linear, multiple linear regression models, we'll talk about autocorrelation, heteroscedasticity, we'll talk about the different tests of autocorrelation, heteroscedasticity, we'll talk about regression to the origin, and from there we move into logistic regression, talking about logistic regression as a classifying algorithm, right? We'll talk about MLEs, we'll talk about OLS algorithms, and finally we move on to time series, right? Because there is a certain similarity of time series and linear regression models which we need to explore, right? So these are the three broad methods that you would require for developing your next 12 months PV and adjusting them to your macroeconomic variables, right? And we'll talk more about, or we'll also talk about some very critical macroeconomic variables over here as well, right? And from there we'll talk about downturn approaches, we'll talk about very good scenarios, we'll talk about baseline scenarios and so on. So these are some of the important things that the way the discussion shapes up in the next stage, right? Now, having said that, I'll just since I'm talking about the macro, I'm just talking about the statistical models, right, in place. So another very critical model that we would have over here for developing PD models will be the survival analysis methods, the survival analysis model. So to understand IFRS9 modeling methods or modeling approaches, we need to understand that how long an account will be there or will be surviving in the books of the bank before it defaults, right? So, so if you want to understand the lifetime approach of an account, that is where survival analysis will be coming in. So that is another approach that we would be kind of taking it up, and over here we would be exploring each of these measures. We'll be exploring each of these each of these each of these modeling methods over here in on the SAS platform itself, right? So we'll do quite a lot. We will be obviously doing logistic regression in SAS, but linear regression and time series is something which doesn't find a place while I'm talking about credit risk modeling. It's mostly the show of logistic regression, survival analysis, right? And you get to see some kind of linear regression, yes, when you are talking about EAD models, but again for LGD or EAD models, but again in LGD models, the distribution is such that it's mostly your beta regression or your gamma regression of the sort. So OLS is not always the suited model, right? So, but over here we will be exploring these three models for your next 12 months point in time forward-looking period, right? So we'll see how the so basically how the PD model is developed, right? What are the key variables? That is something we'll be talking about in more details when we talk about CRM, right? But when we talk about IFRS9, we'll be talking more about, we'll try to understand that given that there is a PD model, right? How do I bring in the macroeconomic variables? So how do I identify those macroeconomic variables, which is there? So given my actual default rates, how do I bring in those macroeconomic variables with me, and how do I try to develop the model and so on, right? And we'll be looking into this incorporation not only from the generalized approach perspective, but we will also be looking at from the simplified approach perspective, to which I'll come down later, right? So is this framework clear to us now? Before I go into the modeling methods in details, I just want to create that framework of modeling first, right? The modeling framework first, and then we'll go to the next parts. So any questions up to this point? Yeah, so is this part clear? Anshu, Pradeep. I mean, is the approach clear? The next stages of the approach, is this part clear? Perfect. Great. So, guys, just give me a minute. I'll just be back and we'll get started. Okay, fine. So let's now talk about some important macroeconomic variables. We'll talk about the transformations, right? And then we'll talk about scenario design. Key, how is the scenario, the things are computed, and then we'll talk about how the final ECL figure would come up. So this would give us an end-to-end understanding of the framework, or the steps that you take to create a IFRS 9 model for using the generalized framework. Followed by this, we'll talk about the trade receivables and the simplified approach, how it is done, right? And again, how it is adjusted to macroeconomic variables to get the lifetime expected credit losses, right? Now, once these two are done, then we'll take up each of these modeling components. We'll see how they can be done in SAS, right? So we'll have the loans which have been given. So again, we'll go back to our German bank data, right? And we'll put ourselves as on a given date. We'll see their amortization schedules, right? And we try to develop the IFRS 9 models for the accounts, right? So we'll go back in history at a point in time. We'll see how they are created. We create the data sets from there, and then we'll try to find out the probability of default and all these informations from there, right? So so again, those data sets that we have used, they'll again keep on coming back. Apart from that, we'll talk about, so once we have completed this, right, we'll talk about commercial products, right, and how is it that IFRS 9 applies to that. So first my primary objective is to talk about an end-to-end framework for developing the IFRS 9 model, explore each of its components, right, and see how that particular model can be developed, how the feeder models are developed, right? So how to understand how time series models are developed in SAS, how co-integration is done in SAS, how intergranular causality would be done in SAS, how linear regression would be done in SAS, how logistic regression would be done in SAS, right? And then to understand how other approaches, like the survival analysis, pseudo-torsion method, how are these being implemented in the SAS platform, right? So we'll understand those, and then we'll see how role rate analysis is being done in SAS, and then how the simplified approach boils up. So these are so this is the way in which we'll proceed. But just for now, for the immediate next steps, right? So once we have identified the interrelation between macroeconomic variables, we'll introduce some more macroeconomic variables, right, which are most used, and from there we'll go take up the next step. Clear? So is this approach okay with you? The approach that I'm talking about? Perfect. Okay. So let's see. So the next important variable that we have with us is is the unemployment rate. Is the unemployment rate. Unemployment rate. So what is unemployment rate? Unemployment rate is the percentage of people who are unemployed out of the total workable force, right? So given the overall size of the labor force in the economy, what exactly is the unemployment rate, right? So percentage of people unemployed percentage of people unemployed out of the total workforce. So percentage of the people unemployed as a part of the workforce, right? Now, obviously, one thing you can clearly understand is that if I plot GDP on one of the axes and I plot the unemployment on the other axis, what you will see is that in an unemployment versus GDP, it will be a negatively sloping straight line, right? So over here you have GDP, right? And over here you have unemployment rate. Unemployment rate. So over here, what you expect to have generally is a okay. So now, what we can generally expect is that when GDP increases, right, the unemployment rate also increases. Yeah, hi guys, can you hear me now? Hello. Okay, there was a fall in the connectivity. Okay, so over here, if you have a look into this, you will see that yeah. So what you see is that whenever you are choosing a certain GDP, right, corresponding to that, you're always choosing an unemployment, right? Because given the productive capacity of an economy, there will always exist and unemployment. So what we can generally say is that when the GDP or the output of an economy deviates from its average long run average output. So let me put it at y bar n. N stands for the natural level of output, right? So this will be some beta 0, or this will be proportionate to the percentage change in unemployment and vice versa. So basically what you can say is that whenever you are trying to identify a certain level of output, right, so there is always an existent unemployment, so which is u minus u bar n. So this is beta 0 plus beta 1 y minus y bar of unemployment from its natural rate, from its long term or historical natural rate of unemployment, is is proportionately related to the difference of y from its long run average output, right? And this beta 1 is generally is negative, is a value which is less than 0. So beta 1 is negative. Right, so u minus u bar n, so which is beta 0 plus beta 1 y minus y bar n, right? So basically when unemployment deviates from the natural level, so out the, or let me put it like this, when output deviates from its natural level of out from the long term long run natural rate, there is also a deviation observed in the unemployment. So corresponding to any optimal level of output chosen by a policy maker, there would always be an unemployment. So you cannot choose any point where there is zero unemployment and full employment, and you have full output, right? Well, I mean that's not really a feasible choice. So a policymaker always chooses an output with its unemployment rate, right? So therefore whenever we are developing models or whenever macroeconomic models come in, unemployment rate also becomes a very important variable, because unemployment rate, any percentage increase in the unemployment rate, right, over the recent periods, will directly impact the delinquency of the bank's portfolio, right? So unemployment rate is a very critical variable to assess this point in time forward-looking macroeconomic, point in time forward-looking PD estimate, because this directly impacts and directly and positively impacts the delinquency rates. So basically, if in a macroeconomic variable, if in a macroeconomic model, if I have output and I have unemployment, right? So I can say that where the moment output starts falling, right? So output starts falling and unemployment starts rising. The gap between the two is the time taken by the economy to react to the delinquency rates, or that's the time taken by the delinquency rates to respond to the changes in output. So basically, if you see that, given if you feed in output and you get the unemployment, right, the unemployment would directly map to your delinquency rates, right? So if you can predict the unemployment rate, you can directly predict the impact on the delinquency. And unemployment, let's say output, the increase in output takes some time to generate the income, and then the unemployment, this thing comes in. But So the impact on delinquency rates or on the falling bad rates for output is gradual, but unemployment would react very quickly, because the moment a person loses his job, the next month he cannot pay his EMI. So if unemployment increases, the this month, the delinquency rates will start increasing in the bank within the next 2 to 3 months, right? And in the next 3 to 4 months, maybe the next 1 quarter, the default rates will start increasing. So unemployment rate is much more predictive, or it's much more quick to explain, or the response of delinquency to unemployment rate is much quicker than the response on output, right? So because this directly impacts the delinquency rates, impacts delinquency, right? So so these are a few macroeconomic variables, which would impact or which would play a very critical role in designing the point in time model, right? So any questions about the unemployment side? Because one more thing, because unemployment also has a very critical or has a very deep relation with the inflation rate. So because when unemployment increases, right, so there are the demand for the goods and services are much lower, hence the production is lower, hence the strain on the resources are lower, and hence your price levels are lower. So if you are choosing a level of inflation, again you are also choosing corresponding to it an unemployment rate, right? So if you see that your prices in the economy are going down, a deflationary economy is pursuing, you know that after a point of time, the the unemployment rate is again going to go up. So there is also a relationship between the price levels and unemployment rate. So there are some important variables, right? So we have talked about the price levels, we have talked about the output, we have talked about unemployment rate, we have talked about interest rate, and so these are all they are all connected and they're all entangled in a very over deterministic fashion, right? So this relationship between output and unemployment is called something as an Oken's law. This is known as Oken's law. Oken's law. And the relationship between your price level and inflation, inflation and unemployment, is known as the Phillips law. So these are important associations, these are important equations which talk about the long-term association between the macroeconomic variables. They talk about over determinism. So they say that, okay, whether is it unemployment which causes output to fluctuate, or whether it's output which impacts unemployment. So most of these laws have shown that yes, it's output which impacts unemployment, and there is a unilinear causality between the two. So if you look, the output is going down, the unemployment is going to increase, right? So when the output gradually increases, the unemployment goes down. It's not the other way around, right? So if I want to use unemployment, right? So there would be an association between unemployment and output. So if I do a Granger causality check and I look into it that yes, the unilinear causality lies from the output side, then I can use only the percentage change in output, right, with the unemployment rate, and from there I can actually take it up, because it's the output movements every time which causes the other macroeconomic variables to change. So if you have a percentage change of output, or you find an optimal lag, or you can identify that okay, that percentage change in output, say 2 quarters behind back the time, would impact my actual rates today. So then this is that would help you develop the model. So not only these, so these are some of the the macroeconomic, the real macroeconomic variables which are important ingredients of the point in time PD model, right? GDP, CPI, interest rates, price levels. So that's under CPI, then unemployment rate, right? So, so these are macroeconomic variables, or these are the variables of the real sector, that is, of the production sector, right? Apart from that, there are financial market variables as well, because movements in the financial markets can also adversely impact the delinquency rate. So basically, if the stock market volatility increases today, right? You see, let's say suppose your stock market is going to a deep area of speculation, right? You invest a lot of money into the market, thinking about that a huge return will churn out, but then the market crash and the market becomes very volatile and you lose your money. Then in such a case, you don't have money to pay your constant EMIs, and that represents a degradation in the repayment capacity of the borrower, and hence the default rates also increase. Therefore, movement in the volatility movements in stock markets, stock indexes, uh, bond interest rates, etc., would also play a very critical role in designing this point in time PD models. Right? Clear up to this point? Okay, fine. Right? Okay. So there are many more macroeconomic variables. So one day we'll just take out the, you know, the central banks macroeconomic variable list, and we'll walk through them when we start with the data side of things. Right? So now, so basically, after you have designed this, this point in time PD, when you have identified your macroeconomic variables, and you have created your forward-looking point in time PD, estimate the next thing over here is, so you will compute the LGD EAD and you get your ECL figures. Now, if you are computing your PD as a function of macroeconomic variables, right? So you are also bringing in the occurrence of multiple scenarios, right? And you are attaching certain probability of weightage to those scenarios, from where you are creating the weighted ECL figures. Okay. Okay. Fine. So the next part that we'll talk about here is as follows. So now, yeah, so as I was saying, so basically when you're talking about macroeconomic variables, you need to incorporate the requirement of scenarios, because how whatever the macroeconomic values and the macroeconomic variables will take, that will occur, or that would be designed as per scenarios, right? And corresponding to each macroeconomic scenario, you will so with macroeconomic scenarios, you will get ECL in each of the scenarios. And then what you need to do is you need to weight this with the respective probability of the scenarios to get the actual weighted scenarios, right? The actual weighted ECL. So over here, there would be three scenarios that we would talk about. One is a baseline scenario, another is an adverse scenario, and the next is an upturn scenario, right? And corresponding to each of these scenarios, we will have three ECL figures. So we will have ECL1, ECL baseline, and the next is the ECL upturn. ECL upturn, right? So, and with each scenarios, you'll get a ECL, and corresponding to each scenario, there would be a probability, right? So the next question that comes out over here is that how do we define or how do we design the probability over here, right? So some of the scenario probabilities is determined exogenously, right? So it's mostly business provided. So looking into the reports, the macroeconomic framework and all the economic survey teams, the economic research team gives out an idea that, okay, this is what the estimated probability is of this scenario to occur. This is what the probability is. And given that, what you do is you you weight them by the respective probability of the scenarios, right? Now, the probabilities again, so basically you have certain respective scenarios. You look into that, okay, over the last 10 years or the last 20 years or the last 50 years, how many times have the respective scenarios occurred relative to the overall occurrence of the three scenarios, right? So how many times has the baseline scenario been occurring? How many times has the adverse scenario occurred? How many times has the ECL, your upturn scenario occurred in the last 50 years? From there, you compute the relative weightages and you weight them by the respective probabilities. So finally, what you get is you get a weighted ECL. So the ECL that we get is the WECL, or as we call the weighted ECL. So one is given that scenario A has occurred, what is the uh, ECL that will occur, right? So let's say the probability of A to occur, of BL to occur into the ECL of the baseline. right? So then the next thing that you talk about over here is the probability of adverse scenario.
Tanmay, just a quick question. When ECL is being calculated, do we also consider the forecasted events? Do we factor that into ECL?
Forecasted events as in?
Any future losses that we estimate, is that also put into the provision, or is it
No.
just
So
the
basically,
past?
so when you're computing ECL, you are trying to figure in the or factor in the the future losses. So standing today, the loss has still not happened, right? So you expect that a loss possibly can happen, and that is why you are computing the ECL,
Right. Okay.
right? So, or are you asking something else?
No, that's it. That's it. Thanks. That answers the question.
Because standing today, when I know the losses did not happen, that's why I'm computing the expected credit loss, right? So if that is already, I mean, so basically that is what the expected loss is. So that's where the future loss lies. So possibly it could be a loss, but still not it is a loss. But still it is not a loss. So I'm doing that kind of an estimation,
Sure. Okay. All right.
right? So you have upturn into the ECL of the upturn scenario. So this is what the final output, the weighted ECL will be the final output of your IFRS 9 model, which will be a function of your behavioral factors, as well as it would be a function of your it would be a function of your behavioral factors, it would be a function of your expected credit losses, it would be a of behavioral factors, of the macroeconomic factors, and about the scenario. So the next question that this brings us to us is, the next question that the discussion brings us to is that how do we create the scenarios, right? So how do we create scenarios, or what are these adverse scenarios, what are these upturn scenarios, what are the baseline scenarios? So this is something that we need to talk about next. So guys, just give me 5 minutes time. Let's take a 5 minutes break, and then we'll start on from 1:30 again. So it's 1:24 my time. We'll just start for the next 5 minutes.
This conference will now be recorded.
Hey, hi guys. Okay, so as I was saying, if you have a look into this, just to refresh what we were doing, so we were talking about the scenarios, the macroeconomic scenarios, and the respective and the probability of respective scenarios to occur, from where we would get the weighted ECL figures, right? So now over here, so just to start off, let's try to understand that, like, how are these scenarios created? How is the scenario created? So before we create the scenarios, we need to define the baseline, adverse, and the upturn scenarios, right? Because each of these terms that we have over here, or each of these terms that we use over here, are absolutely relative terms, right? So over here, when we talk about the baseline scenarios, so when we talk about the baseline scenario is a long-run average scenario, right? So this is the scenario which occurs when most of your economic variables are behaving around its average, right? Now, now the adverse scenario would generally occur when your basic macroeconomic variables or your basic foreign variables, they just go down. I mean, there is a reduction or there is a fall in their behavior which is observed. So that is where we have a adverse scenario, right? So the next thing that we talk about is the upturn scenario. Now, when the performance of your macroeconomic variables improve relative to your baseline variables, that is where we say it is in the uh, so there we say that it is adverse scenario. So that's the upturn scenario. So the question that comes out is that how do we define these baseline, adverse, and these upturn scenarios, right? The one way to do it is that you have a business guideline, right? So which talks about a baseline, adverse, upturn scenario. So generally, let's say that my macroeconomic variable is always at a z, right? So then, whenever there is a upturn scenario, the macroeconomic variables go up z zero point 0.5. So they increase by zero point 0.5. And when there is a downturn scenario, they fall by minus zero point 0.5. So this is one way through which we can actually define an upturn and a baseline upturn and adverse scenario. So in order to do that, first of all, we need to define the baseline scenario, right? So now from the baseline scenario over a period of time, what we do is we compute the Z statistic. And from that Z statistic, by adding or subtracting something to it, what we do is we convert it to the baseline, the adverse and the upturn scenarios. However, a more standard practice of creating these baseline scenarios, adverse and upturn scenario, is to perform the mu plus minus sigma analysis, right? So what you do is you stress your baseline figures by a mu plus minus sigma. Then you stress it by plus minus 2 sigma. And then you stress it by mu plus minus 3 sigma. So these are all your so once you have your baseline or your average behavior of the variables, then what you do is you stress them in this manner in order to get the three situations. Right? So we will look into both these so we'll look into both these so what did I say? So into both these approaches, right? So this first one that I am talking about over here, this approach is more of a statistical approach of creating a stress scenario. So this is a statistical approach of creating a stress scenario. The statistical method of scenario creation. Of scenario creation. Of scenario generation. Now this is applied for cases when you are doing a non-statistical approach. You have a series of your GDP or whatever it is. So you convert that to Z statistic and do some kind of an adjustment to generate the baseline and the upturn scenario. Right. So both these also these two are uh, the two respective approaches that we generally have for scenario generation. Right. So let's look into each of these approaches one by one. So let's take this Z-score approach of scenario generation first. So Z-score approach, right? So when I talk about the Z-score approach, so what happens over here? Let's say I have a GDP series. I have a GDP series. I have a GDP series, right? Now, when I have the GDP series, what I do is from this GDP series, I compute the mean of the GDP and I compute the sigma of the GDP, right? Now, from there, what I do is I compute. So, so what I do is, so now for each of the observations, right? So let's say the observations in the series was x1, x2, dot 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 xk, right? So from here, what I do is I compute the z1, z2, and the z zk variables, right? Now, to this, so this zi is created. So when I have this mu and sigma, so each of the zi's are created like xi minus mu y sigma, right? So I'll get this zi, right? So now this series that I have, let's say this is my baseline series, right? So this is my baseline series that I have. So now this baseline series that we have over here, now from this baseline series, I need to create, So this is my baseline. Now from this baseline, what I need to do is I need to create two series. One is the upturn series, right? So where the economy is going through an upturn, and the other is where the economy is undergoing a downturn. I say that to this, if I subtract each of the zi's with a minus, say, zero point 0.2 or a 0.5, I will get the, so my GDP figure, the zeta, whatever zi value I have, if it goes down by minus 2, then it is a downturn phase. And if it is increases by the constant number 0.2, then it is an upturn phase. Downturn. Over here it is zi plus 0.2 is upturn. I have upturn. So this is the downturn and the upturn. Right? So once I have these scenarios, right? So corresponding to each of these scenarios, I can now compute my ECL, right? And then we need to decide on, so given the description of the baseline and upturn and downturn scenarios, we can kind of create a decision. We can kind of create, So, so from there, what we are trying to do is we are trying to create a framework of the scenarios and then weight it by the respective percentages. And from there, we find out the weighted ECL figures, right? So is this Z-score approach clear to us? Okay. Yes. So once we decide upon the weights minimum, so Mrinmoy's question is, so from here, do we compute the weighted ECL and the probability? No, we don't find out the probability from here. The probability is generally assigned exogenously, or we look into the how many, like for the next 20 years, how frequently has the baseline scenario occurred, how frequently has downturn occurred, and how frequently has upturn occurred. And based on that, and on the present outlook of the economy, we decide on a probability weight to each of the scenarios. And then for each of the scenarios, the ECL is computed and weighted by the probabilities to reach the weighted ECL. Right? Okay, fine. So let's take a pause here for the day. Right? In the next class, we'll talk about the statistical measures of creating the stress scenarios. Right? And from there, we will talk about so we'll create a list of the summary of the steps. We create a kind of a flow chart, and based on that, we will so after that we move on to talk about the simplified approach. So using personal loans, we have demonstrated, we will complete the demonstration of the generalized approach in the next class. Then based on the trade receivables concept, we'll talk about the simplified approach, right? So once these two approaches are talked about, from there we'll talk about the methods that we need to understand in order to develop the model. So once those methodologies are understood in, so separately on the SAS platform, after that what we'll do is we'll try to develop a model with the lending club data that we have with us, right? And then we'll talk about the commercial portfolios. So that is going to be the next frame of discussion for the IFRS 9 sessions, right? So thank you for your time, guys. Thank you for your time, and let's catch up next week, right? So just another reminder: next Saturday we are having 2 CRM sessions. On Sunday we'll have 1 CRM and the IFRS 9. Thank you. Thank you for your time. Bye bye. Yes, I'll do it at the earliest. I'll do it today itself. Thank you.